Hello students, welcome back to Tatrisar Physics classes. Today I am discussing one more challenging problem with you, and the problem is based on circular motion of a charge in the magnetic field. That is the basis of the problem. It's the charge when it is projected in the magnetic field, it moves in a circle, it may move in a helix, it may move in any curvilinear path depending upon the direction of the charge motion and the magnetic field. The angle between the velocity and the magnetic field depends on that. But if the charge is projected perpendicular to the magnetic field, if the charge has this direction and magnetic field has this direction upwards, that means the velocity of the charge is perpendicular to magnetic field, then it will move in a circle. And the circle will be around the magnetic field. I mean, if the magnetic field is like this, the circle will be like this. So that the plane of the circle is perpendicular to magnetic field. That is one part. And today's challenging problem is based on that, on this, the motion of the charge in the magnetic field. The problem is like this. It is an alpha particle moving with velocity v. It hits a proton. When it hits a proton which is at rest, both move in the forward direction. Proton has also got some velocity and alpha particle has also got some velocity, and they move in the magnetic field. जब ये magnetic field में move करते हैं, they traverse circular paths. Both of them will traverse circular paths because magnetic field is inwards and the charge is projected like this. So charge projection is normal to the magnetic field. So both will move in a circle. The circular paths are in this direction. This is the circular path, so that the plane of the motion of the charged particle is perpendicular to magnetic field. और ये जो positive charge है, तो ये अपना magnetic field, it should create its own magnetic field opposed to the magnetic field in which it moves. So that gives you the sense of the motion of the charge. I mean, if the magnetic field is like this, the motion of the charge will be like this. But it can be clockwise or anti-clockwise. Will it be a clockwise circle or an anti-clockwise circle depends upon the direction of the magnetic field. So if the magnetic field is like this and the positive charge is projected in the field, positive charge will move in such a way so that it will produce its own magnetic field. Positive charge will produce its own magnetic field opposed to this field. So positive charge will move like this, in this direction, so that positive charge creates magnetic field downwards. So that's one part. It's a alpha particle, it hits the proton. Proton moves forward and alpha particle will also have got some velocity. Of course, its velocity will decrease a little bit. Both will enter the field and both will move circular paths. And the circular paths will be in the plane of the board because magnetic field is inwards. Cross. I show crosses. These crosses mean magnetic field is inwards. Two charges projected in the magnetic field and they move in a circular paths, and the paths are in the plane of the board because the magnetic field is inwards, inside the board. Okay, this problem involves 2 to 3 concepts. First of all, the concept of collision. Then entering of the charge in the magnetic field, how the circular paths are, how they move in circular paths. The second concept. And at least there are 2-3 concepts involved in the problem. So first of all, we will see when these two charges, I mean alpha particle and proton, when they hit each other, what are their final velocities? Because they make elastic collision with each other. So first of all, I must know when these two charges enter into the field, what are their velocities when they enter into the field. Then I should try to understand how the radius of the path in the magnetic field depends upon the velocity and the mass. I have to develop that concept also. But here alpha particle, you know, it's heavier than proton and it is charged also more than the protonic charge because alpha particle contains 2 protons inside the nucleus. And when it contains 2 protons in the nucleus, that means its charge must be twice that of the proton. Okay, now first concept. Elastic collision. Elastic collision. पहला कॉन्सेप्ट जो है वो इन दो का इलास्टिक कोलिजन। और फाइनली व्हाट वी डू, व्हाट इज द प्रॉब्लम, कैसे फॉर्मुलेट करना चाहेंगे हम। We will try to understand and know what is the ratio of the radii of the paths for the two particles. So I will try to know R alpha by R proton. ये मैं निकालने की कोशिश करूंगा in the present case. What is the radius of the circle? What is the radius of the circle in which the alpha particle moves in the magnetic field? And what is the radius of the proton in which it moves in the magnetic field? Then I will try to find the ratio, and that will tell me which radii is larger. Is the alpha particle path radius is larger, or proton radius path is larger? तो वो हमें पता चलेगा जब मैं इनका रेशियो निकालता हूं। Okay, so first of all, what we do is that I want to know the final velocity of these two particles after they enter the magnetic field, because they make the collision before they enter the magnetic field. They make the collision before they enter the magnetic field, but after the collision, the two particles enter into the magnetic field. So I must know what are their final velocities when they enter into the magnetic field. Then the second concept is, why should the charged particle move in a circle in the given field? That is the second concept that we will try to understand separately. Okay. Now, when the two particle general formulation, general relationships in collisions, in elastic collisions, when the two particles m1 having velocity u1 hits a particle having mass m2 and velocity u2, when they hit each other, and after hitting, when they collide with each other, after the collision, they have velocities. Okay, let me say they have velocities v1 and v2, m1 and m2. So m1 particle hits another particle m2 after the collision here, but I should have shown it here in the same dimensions because it is a one-dimensional collision, head-on collision is there, and that m1 has a velocity of v1 finally, and m2 has a velocity of v2 finally, right? Okay. Now, according to the collisions, elastic collisions, this is done by two rules: conservation of energy rule and conservation of energy principle and conservation of momentum principle. Both the rules can be applied, and we have already done that in my own lectures. So here, what is v1? v1 is m1 minus m2 by m1 plus m2 u1 plus 2 times m2 by m1 plus m2 u2. This is the velocity of the first particle after the collision, and these equations have been derived on the basis of conservation of kinetic energy and conservation of linear momentum. Okay, now what about v2? That is twice m1 by m1 plus m2 u1 plus m2 minus m1 by m1 plus m2 u2. These are the two equations which we get. And now I want to apply these two equations to the present case, where alpha particle having velocity v hits a particle proton, and after the collision they have some velocities and enter into the magnetic field. ये दो equations मैं यहाँ apply करना चाहता हूँ. So what I do is, now here is a striking particle is alpha particle. So this one and this one and this one, let me alpha particle corresponds to 1 and proton corresponds to 2. Now I want to find, using this analogy, alpha particle maybe stands for first particle, and proton stands for the second particle. Then I will use these two equations to find the final velocity of alpha and beta particle, now alpha and proton. Okay, now okay, चलिए, तो ये what is v1? v1 is This V1 that stands for alpha particle, 1 stands for alpha and 2 stands for beta. We must keep that in our mind because we will make the substitutions at the last moment. 1 stands for alpha particle and 2 stands for proton, right? Okay, V1 is equal to, what is M1? What is M1 is the mass of the alpha particle. But we must know, before we make the substitutions, must know M1 is equal to 4 times M2. And also, if you want to know charge of the alpha particle, that is Q1 is 2 times Q2. Magnetic field is the same for both the particles because both the particles enter into the same field. Okay, what is V1 by this rule? Now V1, the velocity of the alpha particle after the collision. I mean, 1 stands for alpha particle. So what's M1? That is 4M2 minus M2 divided by this 4M1 is 5M2 into U1. But U1 is V here. U1 is V. And U2 is 0. So we don't need to write here. Okay, 0 plus 0 is equal to, it is 3M1, M2. M2 cancels. It is 3 by 5 V. That's all. We got the velocity of alpha particle after the collision. That means when it enters into the magnetic field, it enters with this velocity into the magnetic field. Number second equation, this one. Okay, I will write it afresh because I remember it. Now V2, that is velocity of proton, is equal to, that is 2 times M1 by M1 plus M2 U1 plus something, I mean M2 minus M1, but U2 here, but U2 is 0. U2 is 0, so this will become 0. U2 is this, initial velocity of the proton, that is 0. So what is V2? That is M1 is 4M2, that is it becomes 2 into 4M2 by 5M2 U1, that is V, is equal to, M2 gets cancelled, that is 8 by 5 V. So I got the velocity of proton after the collision. So what is important is that the alpha particle enters with 3 by 5th of this velocity, and proton enters with 8 by 5 of this velocity. This is given, right? Okay, this I must remember before I rub it off. Okay, now I should write it here so that I remember it. So it is V1 is equal to 3 by 5 V, and V2 is equal to 8 by 5 V. These are the two velocities with which the proton and alpha particle enter into the field. When they enter into the field, they become curved paths, having different radii, depending upon many things, their mass, their velocity, maybe magnetic field, maybe their charge. Magnetic field is the same for both, therefore magnetic field will have no effect on them because it is the same for both. And the charge definitely has a contribution. Okay, let me rub it off. Now the second point about this, the second concept about this is that when a charge enters into the magnetic field, what is the path of the charge? The path of the charge is curvilinear, and in a special case it is a circle. So why it should be a circle? Let me explain that. Second concept. Second concept, that is, you see, what is the force on a charge in the magnetic field? When a charge enters in the magnetic field, what is the force on that charge due to the magnetic field? As you must be knowing, Lorentz force. The force is F is equal to Q V cross B. From here we can understand what should be the path of the particle. What should be the path of the particle? So what does this equation tell us? This equation tells us that the force on the charge in the magnetic field, वो force जो है वो velocity को perpendicular होना चाहिए और magnetic field को भी perpendicular होना चाहिए. That is what the equation tells, because it is this F is perpendicular to V and B. It's a cross product. So when F is perpendicular to V, that simply means that direction of velocity changes, not the magnitude. So magnitude of velocity remains the same, only direction changes. Okay. In addition to that, if velocity and magnetic fields are also perpendicular, although the equation does not demand that, if we make that, अगर हम बनाते हैं, अगर velocity और magnetic field को भी हम perpendicular बनाते हैं, तब जाकर if speed remains constant but the direction of velocity changes, the particle has to become a circle. Something like this. Let me explain it. It is like, it is magnetic field, let me suppose. Okay, it is magnetic field. Here it is a charge with velocity v. It enters the field, and when it enters the field, it has a velocity v. Okay, magnetic field is inwards. Magnetic field is inwards, and this is velocity. What should be the force? The force should be like this. Magnetic field is inwards into the board, and velocity is in this direction. So velocity is in this direction, and magnetic field is inwards, force is upwards. It is velocity, it is magnetic field inwards, it is the force. Because force is given by V cross B, this force. And due to this force, the velocity changes. And here, let me suppose velocity direction is this, but force again towards the center to be perpendicular to V. And F is anyway perpendicular to magnetic field, which is inwards, but it has always to be perpendicular to V. So this direction always changes, and force is always towards the center. So this force is, magnetic force provides the centripetal force, because as you know, when a particle moves in a circle, the force always towards the center. So here the magnetic force provides the centripetal force. How much is the magnetic force here? The magnetic force is QVB. Why? Because V and B are also perpendicular. So it is QVB. It provides the centripetal force mv square by r. 1m gets, V gets cancelled, and r is equal to, V gets cancelled with 1v, and r is equal to mv by qb. That's all. So whenever a charge enters into the magnetic field, what happens that the force is perpendicular to velocity, and velocity itself is perpendicular to magnetic field. And what happens, the magnetic force acts towards the center of the center. That means it provides the centripetal force. When it provides the centripetal force, the particle moves in a circle. So the equation is very simple. The magnetic force QVB is just equal to mv squared by r. So that will give you the radius of the circle. So from here, radius of the circle depends upon mass. It becomes upon the speed of the particle in the magnetic field. It depends upon the charge. It depends upon the magnetic field. That's it. So now we are in a position to find the ratio of the radii. How much is the radius of the alpha particle in the magnetic field? How much is the radius of the proton in the magnetic field? I can find their ratio, and that ratio will tell you. वो ratio हमें ये बताएगा कि कौन सा circle बड़ा है, alpha particle का circle बड़ा है कि proton का circle बड़ा है in the magnetic field. Okay, so let me now solve the problem. Now I am in a position to solve the problem. Now have a look. Radius is equal to mv by qb. But what about the radius of the alpha particle? Is alpha here? It is 1 here. It is 1 here. It is 1 here. And it is, magnetic field is the same for both. So we don't need to label it as 1 or 2, because magnetic field is the same for both. Okay, now what about the radius of the proton? A radius of proton does not mean protonic radius. Radius of the proton means what is the radii of the circle in which the proton moves in the magnetic field. That is m2, v2, q2b, because 2 stands for proton. So I want to find the ratio. The ratio is divide the 2. When I divide the 2, what I get? R alpha by R proton is equal to m1 v1 by q1b multiplied to उल्टा करके q2b by m2v, m2v2, yes. Second step goes to R alpha by R proton is equal to m1 by m2, इसको मैंने पहले लिखा, into q2 by q1 into v1 by v2, v1 by v2, right? And B cancels off. Okay, now let me substitute these, because I know proton mass is 4 times the alpha particle mass is 4 times the proton mass, and charge of the alpha particle is 4 times the charge of the proton, and 1 stands for alpha particle and 2 stands for proton. Don't forget that. Okay, now what about R alpha by R proton is equal to m1. What is m1? m1 is mass of the alpha particle, that is 4 times the mass of the proton. Okay, what is charge of the alpha? It is charge of the alpha particle. Let it be q2, write it down like q2. But it's q1, that is charge of alpha particle, that is 2 times the charge of the proton, because q2 stands for proton. What is v1? That is velocity of the alpha particle, that is 3 by 5 v divided by, what is velocity of the v1 is velocity of the alpha particle, that is 3 by 5 v after it enters in the magnetic field. तो v2 कितना है? v2 तो velocity of the proton है. v2 is velocity of the proton, and then after it enters the magnetic field, that is 8 by 5 v. v cancels, and 5 also cancels. It is m2 cancels, this cancels. It is 8 will be here. It is 4 2s are 8 here. So what is the answer? The answer is R alpha, radius of the paths of the alpha particle, and radius of the path of the proton is equal to, that is 3 divided by 2 to 4. That is the answer. That means the radius of proton will be more. Radius of proton will be more than the radius of the alpha particle, because for proton it is 4 here, for alpha particle is 3 here. So radius of the proton is more than the radius of the alpha particle. So Rp is greater than R alpha. That is all. So this was the problem which involved the collisions, which involved the magnetic field, which involved the circular motion, and all these together becomes a challenging problem. So again, I ask you to download to subscribe to my YouTube channel, and also download the application Tantray Sir Physics Class, which you can download from Google Store, and that will help you in doing objectives and problems, whatever is available there. Thank you.